Welcome back. A point that is worth discussing that we haven't really touched on in detail up to this point is a distinction design-wise about templates. It's important to understand when to use them because it's sometimes tempting to use template every which way, and one can easily err doing that. So let's summarize a little bit. Templates fundamentally provide polymorphism. They provide what's called let polymorphism. They allow us to be generic with respect to some other type, which is a quite complete different notion from inheritance, which is also a form of polymorphism, but inheritance is subtype polymorphism. So template are let polymorphism, inheritance is subtype polymorphism. Two forms of polymorphism, but with completely different intent. Now, here's an example of a template. You have in C++ the notion of tuple, or the notion of pair, and you can create a pair of two types, A and B, so that you can create a pair of two values. So, for example, you could say pair int, or pair int double, or pair int char, right? So here we have pair AB, which is a pair of two values of type A and B, type of the first element, type of the second. Then we have another pair with two values of two different types, C and D. And then the question comes up, or the intent comes up, that someone wants to take both pairs, the pair of AB and the pair of CD, and put them inside the same container. For example, make a vectors of pairs and store both this one and that one in the same vector. And guess what? It does not work. And there is a simple reason for that. Even though both are pairs, they're not the same type, because the type of the first one is a pair of AB. It's not just a pair. It's a pair of AB. And there is no relationship between an abstract pair type and the concrete pair type. That is, you do not have a relationship if you think of this as, oh, I have a template class T1 class T2, and then I say class pair of T1, T2, of course, right? This type and the type pair int char, these two types one is a specialization of the other, yet it is not a subtype of the other. This is not a subtype of that. I cannot say that, yes, they are pairs both, this one specialized that, but it's not related in any other way. In particular, I cannot make a vector of generic pair and store a concrete pair into it. Those types are not related, right? So this is not a subtype. So in terms of subtyping, I would write it like that. If it were, or subtype is the other way, I would write it like that. But this is absolutely wrong. It is not a subtype, right? So I cannot interchangeably use this with that. And of course, if you make up a brand new type, which is pair, float, and here, I don't know, you make it int pointer. Well, again, these two types are also unrelated, right? No one's related in that thing. You do not get that. If you wanted to have subtyping, you should have used polymorphism and inheritance, right? That form of inheritance. Inheritance polymorphism is cool if you want to have subtype. So you could do that, but then you don't get templates. So you have to keep these two things really distinct in your head when you do a design. It's not because you have instances of a polymorphic type that these types are related to this one via subtyping. That's not the case at all. You'd have to build that in if you wanted that to be the case. So where do you use template? Well, typically you use them each time you talk about generic containers like vectors, lists, graphs, heaps, priority queues, any kind of queues. Think about it. These things, you want to have a list, a vector, an array, a graph of certain type. When you have a graph node, the node may contain attributes that are integers or strings, so that makes sense to be polymorphic with respect to the type of value you store in the node. Same thing if you're storing something on a graph arc, you might want the arc to be polymorphic so that you can have one implementation of a graph, and then you can make various specialization of your graph where what you place in the arc is different. Sometimes it's a floating point, some other times it's going to be a string. It depends on what you want to do. So in those cases, it makes sense to use let polymorphism. It's also great when you write generic algorithm. You've seen that. We wrote merge sort, we wrote heap sort, rewrote find min or find element. All of these are operating on containers that, of course, are generic. So if you want the algorithm itself to be generic, well, it should also be parameterized by a type. And what you're getting is multiple instantiation of the different algorithm, but they're not related through subtyping either. If you want subtyping, do not use template. Use inheritance. That's a very basic concept, and one that is worth revisiting again and again and again to really appreciate the difference between the two. So that's all I wanted to do on that short little segment, but it's a common confusion and a source of discomfort for students when they don't know, oh, should I actually make it a template or should I use polymorphism? Remember, subtype polymorphism. Remember that these are not your only option. You can always encapsulate as well and use delegation, right? So there are multiple mechanisms in object-oriented languages, and generic programming is not the be-all solution to your problem. You have alternative design tools at your disposal. It is a matter of getting practice to recognize when a certain design practice is better suited for your problem. When do you use template? We've discussed that here. When you use polymorphism, that's really when you want to have subtype, right? So polymorphism is really the is-a relationship. So you can say things like a car is a vehicle, and therefore this is subtype polymorphism. It makes sense to do that. You can also use encapsulation to actually define aggregates of multiple things. So for example, a car has wheels. That's delegation, right? So this is a common exercise that you would do in a software engineering course, and it just comes natural the more you do it. The more you practice, the easier it becomes to make the distinction between let polymorphism, subtype polymorphism, and encapsulation. These are different concepts, and you should use them judiciously when you're designing a solution for an application. With that, see you next time.